Okay, so we are going to take a look at 7.3 similar triangles. And so we have a couple of theorems and a postulate. So it's kind of like when we had side angle, side, 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 side. These are just going to be for proving triangles are similar. No worries, there are no proofs, okay? But you still need to be able to apply the theorems and postulate. Okay, so we're going to start off with the first one. First one is the angle-angle similarity postulate. We can just abbreviate this by writing angle-angle, and then for similarity, we're just going to use that little squiggly line. So this just says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So here we can see angle A is congruent to angle F. B is congruent to G. Therefore, triangle, we'll say ABC, is similar to triangle FGH. Again, just making sure that the angles match up. Now, the reason we don't have an angle similarity postulate is just if there's already two angles, automatically these third angles, we had a third angles theorem in the first semester, those angles are going to have to be congruent. But really, we just need the two. Okay, next one, we have side similarity theorem. So side similarity. Now, these are not congruent, okay? Angles are congruent, but sides, we say, are proportional. So if the measures of the corresponding sides of two triangles, so all three, if they are proportional, then the triangles are similar. So that just means they have to have the same ratio here. Okay, so we would, and you can kind of see it on mine here with the color. So JL, right? So this has the same proportion to MQ as JK is to MP. And that has to have the same ratio as LK to QP. And then we can say triangle LJK is similar to triangle QMP. Okay, the last one, so there's only three. The last one is side angle side similarity theorem. Side angle side similarity. Now, remember how I said with angle, the angles were congruent? Same thing here, okay? So even though it's side angle side, the angle in the middle has to be congruent, whereas the sides are going to be proportional. So you'll see it says two sides of one triangle are proportional to two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So here we can see that RS and XY have the same proportion as ST and YZ, but we need to know the included angle, where those two sides meet. Those have to be congruent, and then we can say triangle RST is similar to triangle XYZ. Okay, determine whether the pair of triangles is similar. If yes, we're going to state the reason, and we're going to write a similarity statement. So again, if they're similar, we have three options. We have angle similarity, side similarity, and side angle side similarity. Okay, so the first one, well, let's see. We have in triangle PQR, and we want to compare that to the other triangle, STR. So how do we know which to correspond? Well, if we're going to compare a side, so for example, let's say I am starting with 8 in the little triangle on the top. Okay, so 8 since that's the biggest side in triangle PQR, I have to compare that to the biggest side in the other triangle. So let's see, 8 over 20. So that'll reduce. So we could divide the top and the bottom by 4. So that'll be 2/5. Okay. Then if I check 6, well, 6 is the middle length, right, out of 8, 6, and 5. So I'm going to correspond that to 15. So let's see here. 6 over 15. I can divide the top and bottom both by 3. So that will be 2/5. Okay, so far, these two check out. Now let's check the smallest side. So 5 corresponding to 12.5. Now there's a couple ways that we can convert this to a fraction without a decimal. We can multiply the top and the bottom by 10. We can multiply the top and bottom by 2. It doesn't matter. So the reason I multiply by 2 is that would get rid of the 0.5. So that would be 10 over 25, which does reduce to 2/5. Okay. So this one's going to be yes. And our triangles that are similar, I have PQR will be similar to triangle STR by side, side, side similarity. Now, some of you may have thought, what about the vertical angles? That's fine. So if you want to do the vertical angles in the middle, you could just compare 8 and 20 and 5 and 12.5, and that would be side angle side. So that's fine. Sometimes there's more than one reason that we can have two triangles that are similar. Okay, next one. All right, here what we have is we're actually going to compare this little triangle to the big triangle on the outside here. Okay, now, first thing I notice is they actually share an angle. So we already have a pair of angles that are congruent. Let's compare now some sides. So I'm going to compare 8 to the entire side here, which would be 8 and 4 combined, which would be 12. So 8 and 12, well, I can divide the top and bottom both by 4, so that's going to give me 2/3. Then on the other side, I have 10, and I can compare that to the entire side AB, so that'll be 10 plus 5, which is 15. And if I divide the top and bottom both by 5, I get 2/3. So these two are congruent. So my answer here is going to be yes. So triangle AEF is similar to triangle ACB by side angle side similarity. All right, next one. Okay, so I don't have any sides at all. So the only option is angle similarity. Well, I have a pair of right angles, so there's one pair of angles that are congruent. And in the first triangle on the left, I have an angle that's 44. Well, since all angles have to add up to 180, this missing angle would have to be 46 degrees. And in the other triangle, if I have a right angle and 47, this one would have to be 43 degrees. So as you can see, I don't have two pairs of congruent angles. I only have one pair, angle C and D. So these are not similar. And if they're not similar, you don't need to write anything. We just don't have enough information here. Okay, let's look at D. Okay, these indicate that the lines are parallel. So I know I have angle R congruent to angle W. Those are alternate interior angles. I can also say X and T. So I have no sides here, but I do have, two pairs of angles. Some of you might have used the vertical angles, and that's fine. So I have triangle RXS is similar to triangle WTS, and this will be angle-angle similarity. Now, if you wrote angle-angle-angle similarity, I wouldn't mark anything wrong. It's fine. It's just the postulate is just angle-angle similarity. Okay, let's take a look at E. Okay, I see that there are a pair of angles. And let's see, I can compare 4 to 5. Okay, there's nothing I can do to reduce that. But if you notice, I would have to compare 8 to the side over here, which we don't know what that is, but we could do Pythagorean theorem to solve. So, for example, I can say, okay, let's call this x. So let's look at the triangle on the right. I have 5 squared plus 10 squared equals x squared. So I have 25 and 100, which is 125. When I take the square root, well, I'll get 5 root 5 for x. So I can go back here and 5 root 5. So if I do 8 over 5 root 5, there's no way these are going to be equal to 4/5. Okay, so these are definitely not similar because the corresponding sides are not proportional. Okay, one more of these. We have F. Okay, I don't know any of the angle measures, so the only option here would be side similarity. So let's take a look. Let's say I want to compare 9. So again, when it's drawn in a different kind of orientation, we just need to make sure we match up corresponding sides. So if 9 is the smallest one in DEF, we have to compare that to 3. So 9 over 3 has a ratio of 3 to 1. 21 is the next biggest side, so that has to correspond to 7. Okay, so far we have a ratio of 3 to 1. Let's check the last two sides. So we'll compare 25 to 8 1/3. Now 8 1/3, I'm going to rewrite that as an improper fraction. So that will be 8 times 3 plus 1. So that'll be 25/3. So when I put this over 25/3, I can multiply by the reciprocal, and notice we get 3 to 1 again. So all three sides have the same ratio. They are proportional. So yes, triangle DEF is similar to triangle. And then again, you just have to make sure that you go in the right order. This will be ACB, by side similarity. Okay. Example number 2, find the value of x. So since these two triangles are similar, right, we have parallel lines, so these pairs of angles are going to be congruent. So by angle-angle similarity, I can see 2 corresponds to 5, the same way as x minus 1 compares to x plus 5. Now that's not the only way to set up the proportion. Okay, some of you might want to do 2 over x minus 1 equals 5 over x plus 5. You know, there's a variety of different ways, but in the end we should get the same answer as long as you're comparing corresponding parts. Okay, I'm going to cross multiply. So I have 5x minus 5 equals 2x plus 10. 3x equals 15. So x equals 5. Okay, over here, we're going to do the same thing. Notice these angles are already labeled as congruent, and these are vertical angles. So we know these are similar by angle-angle similarity. So I have 8 compares to 10, the same as x plus 6 compares to 2x plus 3. So we're going to cross multiply. Now, some of you, if you want to take 8 over 10 and reduce that, you feel free. It just makes, you can make that into 4/5, and then you just have smaller numbers to work with. It doesn't matter. I'm just going to leave them as is. So I'm going to multiply 8 times 2x plus 3. So I have 16x plus 24 and 10x plus 60. So we get 6x equals 36. So x equals 6. Okay, the last type of example we have here, we're going to identify the similar triangles and find each missing values and measures. Okay, so we can see these two triangles are similar by angle-angle similarity. First, we'll write a similarity statement. So triangle, we'll call it DEF, is similar to ABC. Okay, and to solve for x, we're going to set up a proportion. Okay, so that means 3 corresponds to 15, the same as x corresponds to 45. We can cross multiply, we get 15x equals 3 times 45. So that's going to be 135. I'm going to divide by 15, and we get x equals 9. And then DE happens to just be x, so that's going to be 9. All right, next one, let's write the similarity so we can see ABC is going to be similar to DEF. Okay, and this one's kind of flip-flop, so I can compare x to x minus 4. That has to be the same as 5 is to 3. So I'm going to cross multiply. So I have 5x minus 20 equals 3x. 2x equals 20. X equals 10. If I plug back into AB, that's just going to be 10. And I plug into DE, that's going to be 10 minus 4, so we get 6. Okay, last one here. Okay, so we're going to compare, since these lines are parallel here, right? These are corresponding angles, and these are, so these two triangles, so we have like the little one inside of the big triangle, right? Okay, so let's start with the similarity statement. So that's going to be triangle ABE is similar to triangle ACD, and you can pause it also if you want to try this one on your own. Okay, to solve for x, I am going to compare 3 to 5, and then I'm going to compare x to 3.5. So I'm going to cross multiply, so I get 5x equals 10.5. Divide both sides, and we get x equals 2.1. Okay, then for y, well, I'm going to use the same ratio. I'm going to use 3 over 5. And on the other side, I'm going to compare y. Now be careful, I want the entire side, so if I combine y and 3, that's going to be y plus 3. Now I'm going to cross multiply, so I get 5y equals 3y plus 3. Sorry, I forgot to multiply that up. That's supposed to be 3y plus 9, right? Don't forget to distribute. So 2y equals 9. So y equals 9 over 2. or you can write 4.5, it doesn't matter. All right, and that's it for 7.3.